Thank you very much. Let's move on with the next presentation. The next presentation is going to be given by Dani Tost from the Technical University of Catalonia, Maria Ferrer from the Rovira i Virgili University, and Mr. Ferrer from the Goodman Institute. You have the floor. Thank you very much. Thank you very much, DTR for all, for inviting us. This presentation will be divided in two parts. In the first part, we will carry out an introduction about virtual environments. What are they? What are their uses? And in the second part, we will talk about a practical case that we have been talking about in the last few years, which is these neuropsychological virtual environments and the rehabilitation associated to it. Alberto García Molina from the Goodman Institute will talk at that time, and the demo will be carried out by my colleague Mar, who's at the projection area. And I say hello to her right now. So we've been working on graphic computer science for a long time, but it was difficult for us to apply our knowledge to rehabilitation. We did that together with the Goodman Institute and with Dr. Germa Toros that helped us collaborate together with the Computer Science and Applied Mathematics Department from the Rovira i Virgili University, where Dr. Garcia and Dr. Ferrer worked there for a project, a health project carried out in Catalonia. This was the beginning of a project, but now we have enlarged this project, and this is the neuro learning project we're working in right now. And in the neuro learning project, there's also the collaboration of companies such as Vodafone, Barcelona Digital, ICA, and other research centers such as the Cognitive Neuroscience Research Group from the University of Barcelona, also an institute collaborating with the University of Barcelona, and an institute collaborating with the Technical University of Madrid. This is the graphic virtual part of the project. We have the different working groups projected on the screen. Ricard and Mar are also working in the project, and they're here, and there are many other colleagues that unfortunately are not here with us. We come from graphic computer science, and this is a relatively old area. We say that this started in 1963 with the thesis of Evan Sutherland, Ketchpad, that was the name of the thesis, where we were working with drawing different vectorial screens. Right now we have pixels, but at that time it was vectorial, and we could draw on those screens. And with digital illusions, that was the video that started from the very beginning, we have evolved quite spectacularly, and we have an evolution in hardware and graphics software as well, because these two aspects go hand in hand in technology. From the point of view of software, this is what we used to work with, and we have always been focusing on hardware as well, trying to cover its lackings and make the most of the opportunities that these systems were offering to us. Right now, we are at a peak moment in hardware. I'm talking about these different output devices that are very powerful right now, and there's still room for improvement. In graphic computer science, we have the geometric models. This is the internal representation that we have of objects. Here we have a dog, and for us internally this dog is just a set of shapes, and we just represent its surface, and we can have another projection where we have all of these polygons where we can see that it's an empty shape, because geometry is at the basis of all these mathematical representations. But we do not only work with polygons, we also work with spots models such as the Stanford statue model. We also pile or overlap 3D medical images, and also we use blogging models. It is also very important to take into account the material of the objects. These are the optical behaviors of how an object is with light, if it's transparent, translucent, and also we focus on color, if it's has a flat surface or not. We take all of those things into account. And I'm talking about all of this because this is the core of everything we study, how we work. We have the model right now. Now we have to project it on the screen, and we use projection techniques to do that, to simulate the optics of a camera with more or less realism. And it is also very important to take into account the visibility calculations. When we have to project model or an object in the screen, we need to take into account the point of view of the viewer, as well as the light projected on that object, the shadows and the areas that have the focus of light on. Now we have the materials, but we still need to see how the light is penetrating in the object or if it is rejected by the object. And this is the illumination modeling part. We have had great developments along these lines, and we can have images such as these that you can see on the screen right now. It is difficult to say which one is fake and which one is the real image. We have blur images, and we have this caustic effect at the top where we see this concentration of beams of light in this transparent object. So all of this is the core of our project. The geometrical model, we can project it. We know how to illuminate it. We know the material. What do we need right now? We need to simulate its behavior in the environment. And this goes beyond graphic computer science. We need other disciplines. To model the objects in the environment, we need to simulate the physics of this object. We have represented a table here. There is a glass on top of it. In the virtual environment, we can put the polygons of this glass in this environment of the table. So we need to take into account the collisions. We need to talk about the contact. There should be contact, but no penetration. And we need to calculate the relative positioning of these objects. And beyond collisions, physics is also important to simulate the real movement of objects. If there is a ball, it should fall according to gravity laws. And for that, we need to have a map, we need to have a shape, we need to have the friction forces into account, we need to take them into account. So we need physics as an ally. And we also need to take into account the behavior of the different elements in the context, because those elements that we're working with can have a life on their own. And we need to use other disciplines such as psychology, sociology, that will help us with the behavioral models. And we need artificial intelligence here. So we have physics, artificial intelligence, and graphics and computer science. And finally, we need all of the input and output and feedback devices and mechanisms, so that the feeling that a user has in an environment or the interaction is as real as possible, and the immersion feeling in the context is as powerful as possible. With all of these elements that I've been talking about, models, illumination, physics, in artificial intelligence, we have a virtual environment. Why do we have these virtual environments? We use them right now for video games mainly, but in today's presentation, we want to prove that virtual environments can have another application, especially in the medical field and in the health field at large. And they can help improve people's lives. At least, well, in video games, they can also improve our mood, but they can also have some therapeutic applications. So this is a virtual environment. Let's talk about the virtual reality here. This would be interactive virtual environments, those that we have been mentioning, but there would be two more elements: the feeling of being immersed in that situation, and we can have that feeling through a feeling of presence and also physical sensations with all of the sense input. And to describe virtual reality, we should say that this would be like a stereoscopic device, so we can have this deep the feeling of depth in this situation. Usually we work in virtual environments, but we don't have much experience in virtual reality. I'm talking about the stereoscopic devices here. And today we're going to talk about virtual environments, not virtual reality, as we understand it from a technological point of view. Examples of virtual reality. The first machine was called Sensorama, and it had all of the immersion ingredients that we're looking for: the smell, movement, the stereoscopic immersion, and surrounding sound, so as to have this presence of this feeling of presence. In the industry, there have been great progress carried out along these lines. Here at the bottom, at the right-hand side, we have an example of a cave that we use in the Ford plant. It is a virtual environment, and we reproduce the inside of a car. And this is used in the